Hello. Today we are going to be adding and subtracting polynomials. So for today what we're going to do is we're going to take a look at all of these different things on our screen. So we have variables, but we also have animals. So we want to identify the number of each of those different things and then record our answers below. So let's first take a look at the fish. Okay, so we have 1, 2, 3, 4, 5, 6 different fish. How about our mice? We go 1, 2, 3 mice, and then 2 birds. So what we're going to do now is we're going to do the same idea, but with our variables. So our x's, I'm going to go ahead and circle them. Those are the only ones that are just x's. So this is like it's saying 1x, and this is saying it's 2 more x's. So overall, there would be 3 x's in total. How about our x squareds? So I'm going to circle all of the x squareds. I cannot circle the x squared y because that is different. Okay, so the y makes it a different term. We have x squared, and x squared. So overall, there are 3 of those. And then the x squared y. So we have 5 here, then 3, and then 1 more, make 9 x squared y's in total. So what we have done right now is we have identified all of the like terms and we have combined them. So like terms are going to be terms that have the same degree and the same variables. So terms that have the same, and I'm going to switch that, same variables with the same degrees. So same variables, same degrees. So notice up here we had the x squared. We also had x squared y. Since this had different variables, those are not like terms. Also, this one had x and the next one had x, but they didn't have the same degree. One had x to the first power, one had x to the second power, so they were not like terms. So what we're going to do here is we are going to find all of the like terms and then we're going to combine them together. Just like the last activity, but now they're kind of more of them with x's and y's. So the first thing I'm going to do is I'm going to find all of the x squared, y squared. So there's only 2 of them here. Those 2, in order to combine them, if we have -8 of these ones and -5 of the others, overall there's going to be -13. So notice the coefficient changes, the number out in front, but the term itself does not change. It stays x squared, y squared. So now let's try the x squareds. I see 3 of these. So I'm going to go ahead and combine the numbers out in front here. So I have 14. There's a 1 here, which makes it 15. And then -3 makes it 12 in total. Now let's go through and find all of the y squareds. Oh, there's only 1. Okay, so that would be a 1y squared. Now we go through and we look for our x's. And so there's both of those. If we combine the -15 and the 6, -15 plus 6 becomes -9. Then we have our y's, 4 and 11 make 15. And then our constants, 13 and 22 make 35 in total. So you'll notice we are combining like terms, and while we're doing that, the number out in front changes, but the term itself does not. Also notice this is going from highest degree to lowest degree. This first term has a degree. There's 2 x's and 2 y's. The degree is 4. The next one had a degree of 2. So did the y squareds. And then our degrees were decreasing. So this would be your standard form of your answer. Highest degree comes first. So now let's take a look at it if it's not all broken up like that and it's just written like this with 2 polynomials together. So we're going to simplify Please notice that in between these is an addition sign. So we're just adding them together. So what we're going to do is we are going to highlight the like terms. So 5x squared and negative 3x squared. Notice these ones have the same variables with the same degree. And I noticed the squared was the highest degree. So I'm combining these first. So 5 minus 3 gives us 2. And there's 2 of those x squared terms. Now we're going to do the same thing with our x's. So here we have negative 3 and 6. So negative 3 plus 6 gives us positive 3x. And then our last ones, we have a plus 4, and we're adding it to minus 3. So 4 minus 3 gives us plus 1. So we are combining like terms. So number 2, again, once again, notice there is a plus sign in between. That's important. We are adding these together. So we're going to find our highest degree, and I see a y to the fourth, and I don't see anything higher. So I'm going to combine my y to the fourth. 1 y to the fourth minus 2 y to the fourth becomes negative 1 y to the fourth. So you can write the negative 1, or you could just write it as negative. Then I would look for a degree of 3, and so I actually see a degree of 3 here. There's nothing else to combine it with, so therefore it is going to be plus 2y to the third. Then I look for my y squareds. I'm not seeing any y squareds. Okay, so then I look for my y. I see my y here. I have a negative 3y and a positive 2y. So that's going to become negative 1y. And then my last two to combine here are positive 7 and negative 11. So that becomes negative 4. So before we move on to the next couple of examples here, I want to just do a quick review of yesterday and the different terms that we learned. So if we want to classify this by the degree, we first would have to find the degree of this one. This first term has a degree of 2 because that's the highest exponent. This next term has a degree of 1, and the last term has a degree of 0. So overall, the highest degree you see is 2. And because your degree is 2, that makes it a quadratic function, a quadratic polynomial. The next thing I also want to do is classify it by its number of terms. There are 1, 2, 3 separate terms. Since there are 3 terms, that makes this a trinomial. So this is a quadratic trinomial, and the leading coefficient for this one is 2. So the next one you notice here, there are actually 1, 2, 3, 4 separate terms. Anything more than 3 terms we did not have a name for, so as a reminder, this is a polynomial. And each of these terms has a different degree. I see a degree of 4, a degree of 3, a degree of 1, and a degree of 0. So my highest degree is 4, which means if the degree is 4, that is going to make this a quartic. So this would be called a quartic polynomial. So I just wanted to do that quick review of those terms so that they keep fresh in your head here. Okay, let's go ahead and try numbers 3 and 4. Please notice there is something important here. So you notice that these terms here, that in between them has a minus sign. When you see that minus sign, what you are going to do is you are going to have to subtract every single term that comes after the minus sign. And so what we want to do is we want to actually rewrite this. If you are doing minus and negative, when we distribute that, this first one here is going to become plus. So minus this negative, this becomes plus 2x cubed. This next term is going to be minus, because a negative times a positive is a negative, x squared. And the last term here, minus the negative, becomes plus. So minus negative 2 would become plus 2. So rewrite your second parentheses if it's subtraction, and make sure you're distributing the minus sign to each of those. Anytime it's minus a negative, it becomes plus. My first polynomial does not end up changing at all, so I can just rewrite it. And now it's just an issue of combining like terms. So I'm going to go ahead and group my like terms together. I see a cube here and here. So it's 4 plus 2, which gives us 6x cubed. Then we go for our squared terms. We have a negative 3x squared and now a negative x squared. That would be negative 4x squared in total. The 6x has nothing else to combine with. There are no like terms. And the last one, negative 4 and positive 2 become negative 2 in total. So let's try this next one. You see this minus sign in between them. So as we look at this minus sign, we say, wait a second, I need to distribute this minus sign to the 7. I need to distribute the minus sign to the negative y cubed, which makes it a plus y cubed. And I need to distribute this negative sign to the positive 12y, making it negative 12y. The first expression does not change at all. And after we rewrite it, now we can just go ahead and combine like terms. So y cubed would go first, then y squared, so it's plus 5y squared. Then our y's, which we actually don't, we have 8y and negative 12y. That would become negative 4y. Lastly, followed by our constants, which would be negative 17 in total. So that's the idea here. I'm going to zoom out so we have a full scope here. So adding, you just combine like terms. Subtracting, you change all of the signs afterwards and then combine like terms. So here's what I want you to do. Go ahead and pause the video and try numbers 1, 2, and 3 on your own. When you're done, you can unpause the video and come back here and listen to the explanation here and just double check that everything went okay. Okay, so let's take a look at this. Number 1, when we are adding these two polynomials together, we get 12y squared. Notice that the term itself does not change. It stays y squared. Only the number in front changes. Minus 2y minus 1. For number 2, key thing here is to take this minus sign and distribute it to everything afterwards. So notice that every sign changes. So if that helps you, just change every sign after the minus sign. Then combine like terms and we get negative y to the 4th plus 4y squared plus 2y. And then the last one is asking for the perimeter. So to find the perimeter of something, that means that you need to add all of the sides together. So we can take each of those sides and write them as like addition in between each of them, and then combine like terms. So when we do that, we end up with x squared plus 2x minus 1/2. Thank you very much for listening.